In this video, we're going to start exploring the three-dimensional shape of molecules by looking at the valence shell electron pair repulsion theory, or Vespr. And Vespr is a tool that we can use, or rather a theory we use to determine the three-dimensional shapes of molecules. And for Vespr, we treat electrons as either lone pairs, single bonds, double bonds, or triple bonds. And the whole idea behind Vespr is electrons are negatively charged, so in our molecule we have to arrange our electrons in such a way they are as far away from each other as possible. So let's take a look at an example of that. Let's imagine we have an atom, the central atom, that is bound to three other atoms. Now, there's a covalent bond between each one of these atoms. And this covalent bond is made out of two electrons each. Now, these electrons will repel each other because they are negatively charged. So we have to come up with a way to position these three atoms so they are maximally apart. And the way to do that is to put them in a triangle. Because if you do that, each atom is as far apart as they can from each other. And that is what we're doing in Vespr theory. We're saying, how can we position these groups so that the electrons are the furthest away from each other as possible, right? And we're going to look at 5 basic geometries around a central atom. And we have 5 geometries because we can have a maximum of 6 things binding to our central atom. In reality, it is possible to have more than 6 things binding, but that is extremely rare, so we're not going to look at it. And these 5 arrangements will give us 5 different geometries to work with. Note that we won't be looking at lone pairs in this video. We'll look at the geometry when you have lone pairs in a future video. Also, and we talked about resonance structures, but the great thing about Vespr is you don't need to pick the correct resonance structure as long each resonance structure will give you the same result. So Let's take a look at our geometries here. And by number of electron groups, it means number of atoms bonding to your central atom. So if you have a central atom that is bound by 2 atoms, then it'll be in linear because each of these bonds are 180 degrees apart, which is maximal separation for the electrons. If you have 3 binding groups, you're going to be in what's called trigonal planar geometry, where the bonds are 120 degrees from each other. If you have 4 bonding groups, you're in a tetrahedral, where each bond is 109.5 degrees away from each other. If you have 5 bonding groups, we call that trigonal bipyramidal geometry, where most of your bonds are 120 degrees away from each other, but you do have some bonds that are 90 degrees away from each other. And finally, the last type of geometry you can have with 6 groups is octahedral. That's where each bond is 90 degrees away from each other. So to really learn this, I would suggest flashcards, as it's just a hard and fast rule. If you don't have lone pairs, this is what your geometry is going to look like. And that's really the basic of Vespr theory without lone pairs. It's just saying, what does my different groups look like based on the number of electron groups I have bonded. And that's it for this video. See you in the next one.